Hello friends, already in my previous video I have discussed about the step response of a system and how to get the plot of the step response of a system in MATLAB. Okay, so basically step response is very simple. It is the output of a system when we provide unit step signal or unit step sequence as input of a system. Okay, then whatever output we can get, that is basically step response. Now see, observe and try to understand this clearly. So suppose obviously in DSP we deal with digital signals, right? So let me take discrete signals here. So suppose here in this system h of n we are providing u of n, which is basically unit step sequence. See, for n greater than equal to 0 it is 1, for n less than 0 it is 0, right? So basically, and see in and as an output, which is basically nothing but y of n, we can have this type of response. Now one question you just try to understand. See, first unit step was 0, so for this we can get one system output. Then see, it is for n greater than equal to 0, what is happening? It is taking one constant value, right? So whenever you are processing a constant value by a system, by a particular system, the output whatever we are going to get, that should be same, right? That should be same with respect to time sample. Like I will give you one practical example. Suppose in a piano, you are playing one piano, you press a button. The button, if you press, means continuously same button, if you press, then same sound it is going to produce, right? It should not change. Okay, so but see, it is contradicting in the initial output response. See, consider the output response. See, after this stage we can say that the output is going to be constant, the response, output response is going to be constant. But see this part, observe this time sample part here. In this part it is not taking constant values, and it is like kind of giving some random values like oscillations, like it is giving. Here comes the concept of transient response and steady state response. So basically what it says, see here there is in the unit step input, just observe, at n equal to 0 there is an abrupt change in the input, like high, sudden change. Like I will give you one example of practical scenario. Suppose there is a motor which is connected to our supply voltage. Now as soon as you turn on the motor, very high amount of current suddenly will go to motor, right? So in that case the motor will miss, if the current is constant also, but from current equal to 0 to a very suddenly very high value it is reaching now. So in that case the motor will instantly cannot reach the constant rotational speed. It will take, slowly by slowly it will take some certain time. It may be in millisecond, it may be in nanosecond, but then also it will take some time. Suddenly from 0 rotational speed it cannot go to 20 rpm or whatever you can say. Okay, so that's what, so this is, there is a transition and it will take some time to reach to its original value. So this response, that is after some oscillations, when it is getting, when it is giving one constant response, this is called steady state response. Steady state means, okay, it reached into a steady state, constant output it is giving. But this is called what? Transient response. Okay, because here just we have given very high sudden change in the input, so that it is oscillating like this nature. If you observe the output response only, you will get this type of graph. Okay, now from here there are lots of things which are very important points in control system subject point of view. So I will show you in MATLAB also. So let us directly go to MATLAB. So see, this was my previous code, control A, evaluate selection. Already I have discussed it in my previous video. You can check my previous video. I will post the link in the description. So see, this is the unit step response. Now it is not clear, right? Properly we cannot understand. So I will just add 2-3 lines so that it is clearly visible to us. So hold on. Now plot n comma y, let me give this type of symbol, and grid on also let me give, so that you can understand the values. Okay, control A, evaluate selection. See what we are getting as response. See, observe the amplitude of the output response with respect to time. Initially it is, the oscillations is huge, and slowly by slowly the oscillation is degraded or reducing, and here in this region it is reduced much. Let us increase the n value more. Let us keep it 70. Let us check. See, here now the output is giving one constant value. That means here in the high value of n, like 50 to 70, we can say it is giving one steady state response. But here for lower values of n, see, you can observe the waveform, it is giving random output. So this is called transient response of the system. And here comes some important terms which you going to understand in detail in control system, but I will just give you a quick overview about some terminology of this transient response. So like here, see, in the transient response, see, this is the steady state value, right? And see, this is this point at this time sample, the response is taking peak value, okay, maximum value of the response. So what is that? That the difference between the maximum peak value of the response and the steady state value is termed as peak overshoot. Okay, so peak overshoot is nothing but the difference between this maximum amplitude minus this steady state response amplitude. Okay, so this is one very important terminology. Then another one is, see, this is the steady state value, right? It is just somewhat value in between 1.2 and 1.4. It is taking steady state value. So time taken or time required for the unit step response to reach that 50% of its final value. See, this is the final value. Time taken to reach it up to its 50%. Like here, if you consider 1.2 as maximum, so just above 0.6, the time taken to reach this 0.6 response is called as delay time. Okay. And in this response, observe at this point it is taking maximum value in all over the output response, right? So this time sample is called peak time. Okay, I hope you have understood. And one more very important point is there, which is called settling time. What it says, see, this is our original steady state output response, right? And here this is transient response. Now what will happen, see, transient response is oscillating and the oscillation is died out as we are keep on increasing the time sample, and after a very high time sample it is taking steady state value. So when the oscillation is confined in between like 2 to 5% of the steady state value, that we will call as that time requirement is we will call as settling time. Like see, here huge oscillations are there now, so these points, this time we will not consider as settling time. But see, here if you consider just 1.3 as the steady state response, so just 5% lower and above, if the response is confined, then that will call as steady state. Like this response, see, these are very less amount of deviated in compared to the steady state. So here the settling time will come. So the definition is time required for the unit step response to reach to the 2 to 5% of the steady state response. Okay, sometimes 2% we take, sometimes 5% we take, and according to that formula will vary, which you will going to understand in detail in control system point of view. But these terminologies I just wanted to show you to have a feeling about the transient response and the steady state response. So in this video I have just visualized you what is actually transient response, that whenever it is not reaching to a particular value, it is oscillating, it is trying to reach but it is unable to reach, because suddenly it cannot go to a particular output. Like suddenly motor cannot take one particular rotation per speed, right, or revolution per speed. It will take some time to go. So this is transient response, and this is very very important to analyze the circuit. Obviously from this it is clear that transient response is there for a very small span of time, and for the huge span of time steady state response is there, but the transient response is very important for the designing a system point of view.
Suppose I same example you take, when you just give turn on the switch of the motor, suddenly it gets very high current. Then the current should not be so much high that the motor should burn out, right? So to control that, we should design the system properly. Okay. So here are the three definitions I have written. Just basic simple definition. What is transient response and what is steady state response? So transient response is what will happen at the moment you switch position changes. Okay, so basically as soon as you change the switch, certain change in the input will give result in the output response as transient response. And steady state is what will happen to your system if the switch remains the same position for a long time. Okay, after a long time the response which you are going to get, that is steady state response. And generally, obviously, from the discussion it is quite clear, generally transient lasts for a very short duration. Another very beautiful example on the transient and steady state response can be given, that which my professor taught me. Like whenever you go in a floor via lift, then you just press a button of the floor where you want to go from the ground floor. Now see, the lift goes on, and suppose third floor button you have pressed, so you want to go to third floor, the lift will stop in the third floor. So lift will go up from the floor and from the ground floor, and when third floor will arise, instantly it will not stop, it will decrease its speed, and it will means some transition is there. Then after a certain time, some second it will take, then it will go to a steady state. Then the sensor will understand, okay, we have reached in the third floor. Then what will happen? Then only door will open. In the transition period, if door opens now, then accident will happen with you, right? So this is what one practical scenario where you can relate the transient response and steady state response uh, with respect to practical scenario. So this is all for my this video. I hope that from this video you have at least understood what is transient response and what is steady state response. So if you understood that, that is all about this video. So for more videos related to electronics and communication engineering, please subscribe my channel and don't forget to press the bell icon. Thank you for watching.